Welcome, everyone, and welcome into our September 2024 engineering webinar sponsored by the ABA Broadcast Engineering Services. I want to welcome everybody here. We've been a little lax on our seminars for first one thing and another, but we're back on track and everything, and we're glad to have everybody with us today. Want to remind you that we are underwritten the activities bothly for the webinar and all of our other activities with the ABA system, our classes and other seminars that we put on. We're sponsored by Max Connect Group, and Max Connect Group has been around for a good while and continues to grow. Josh Bond and his group, they're sort of a full service broadcast facility. They furnish everything from the microphone all the way to the antenna and maybe even the tower lights, which are actually above the antenna. But he's involved in a lot of stuff, especially in IP. Has a lot of new situations out, new equipment out, and we invite you to check that out at www.maxconnect. Notice the spelling there, maxxkonnect.com. Check it out and see all the features. And when you do, just drop him a note and tell him that we appreciate that you appreciate him being a part of the ABA and the engineering activities. I missed a slide there. I'm sorry. Let's go back now and talk about what we're going to talk about today, and that is audio, and more particularly the processing and how we go into it. I've invited my good friend Frank Foti with Telos, and I see his cohort, Kirk Carnax, join us too. Glad to have you with us. Frank, what we wanted to talk about a little bit this morning, and you've been involved in audio processing design and processes to set them up and all. And I wanted to ask you a question because I saw somebody talk about this one day, and I knew that you would probably know this more than anybody else. What was the very first audio processor that was ever used at a radio station?
Well, Larry, first of all, thank you for the opportunity to once again spend some time with the ABA group. And you sent me a note yesterday, and I gave some thought to it. The best answer I can offer you, because what we know is audio processing today evolved out of the need for, in broadcasting, for us to protect from overmodulation. I mean, in AM and in FM, the government has a strong restriction, and that no peak level can go beyond a certain point. And so in the early days, you had crude limiters, and to the best of my knowledge, you hear people talk about stories that were, probably the most used products, back in the 50s and 60s was the stuff out of CBS Labs, Emil Borik's group, what was known as the Automax and the Volumax. The Volumax being what protected from overmodulation. I know that Yuri had something known as the BL40, which was a limiter that was widely used in AM. And you hear stories about people using the level devils and products of that nature. But insofar as an audio processor and what we know, I would have to say, and I've always kind of thought that the father of at least multiband audio processing was Mike DeRoe. Mike worked in an AM station, and actually the gentleman that was my mentor, the late Jim Samich, worked alongside Mike and knew Mike really well. And Mike got the idea of, what if I'm able to split the audio into multiple frequency ranges and take each of those separate frequency ranges and process them independently, and then mix the audio back together, and then utilize a final limiter to prevent against overmodulation. And He did that successfully, so much so that, for many years, Mike along with his wife Kay, they would build these things on their kitchen table, put them in the trunk of their car and drive to radio station and install them. So, but the answer to your question, I think it's not that all of a sudden somebody woke up one day and made an audio processor. It grew out of the need that we have to protect against overmodulation for AM, FM. And if you're, wondering, well, can you overmodulate HD? Well, technically no, because, you can't go beyond digital full scale. There is no plus 3 dB full scale. So, you try to go too far, you're going to have nothing but distortion.
Well, the seminar I was watching when the guy brought that question up, he had a rather humorous answer to that question. Was what was the first processor ever used? And what he said was it was a gentleman in a white lab coat sitting in front of a console with a big knob. And if the audio was too low, he would turn it up. If the audio was too loud, he would turn it down.
Yep. Right. I mean, theoretically, well, technically, yeah, that's true. We used to like jokingly say processing by Armstrong, using the arm to, turn levels up and down. But and even in that scenario, there's no way that you can eliminate, short duration, eliminate short duration peaks and things of that nature. So I was just kind of answering it based on, like a device that was stuck in the rack that would ensure that, overmodulation was, didn't occur.
Yeah, I thought his answer was rather cute about that. So the guy sitting there turning the knob up and down, and that
Well,
in reality, that was probably right.
in the early days of FM, I think there was probably that. I mean, you hear stories that, in the early days of FM, of what, modulation monitors, they kind of, the modulation, the needle on the modulation monitor was kind of, lazily moving around like a sleepy VU meter. But today they look like a current meter, based on what we're capable of generating with regard to peak control.
Yeah, that's very true. And as you said earlier, it was initially designed to actually protect you from overmodulation with FCC
Right.
rules and everything. But as time went along, and you might touch on this a little bit, program directors sort of discovered that not only can it be used for protection from overmodulation, but it will also allow you to tailor your sound the way you want your station to sound. Now, that being said, and I'm sure you'll be the first to agree, there is a fine line. You can tailor it as much as you want to, but there's a fine line that once you cross over that fine line, you're no longer increasing the quality of your sound, but you're going the other way.
Well, yes, you're right. I mean, we'd all like to know that there's a free lunch, but there isn't. And, probably the biggest challenge that I've taken on over the last, since 1988, when I got started with this thing, was how do you push that, frontier to, generate that competitive level that program directors are looking for, but minimize the annoyance to the ears. And even still, I mean, there's times, we have, within our little organization, as we develop new things or work on new product releases, there is a point of no return. You can't just keep turning it up. I mean, we jokingly, the whole reason that we call the one product Omni 11 was it's a play off that scene in the movie Spinal Tap. Where the guys talk about their amplifiers are one louder because they can go to 11. And if somebody's out there thinking, well, can you go to 12? Maybe, but then again, it comes back to that subjective feeling, which has to be recognized by the broadcaster of like, how far do you want to go? and we've been accused of, like, people say, oh, your products are louder than everyone else for a certain level of quality. And, why do you keep pushing it? And I tell them, if we don't do it, someone else will, I mean, it's just, you know, that's the nature of the beast. It's the nature of life. It's the nature of business and competition.
Yeah, I want to stay off of my soapbox on the loudness war because
And
I
please,
mean,
Larry, I apologize for interrupting. I'm not here to promote a loudness war. I'm really not. But there are certain broadcasters who say this is what we want to do on the dial, and we will find a product to do that. Knock on wood, I think last go around, marketing tells us that 75% of the time they pick us.
yeah, I think, and the reason I said that was, and sometimes in our classes we get off on a tangent about, and I tell the class, I said I'm going to get off my soapbox here in a minute, but I have never been a big proponent of the loudness war. I think it was a myth. As far as I know, there's no radio made anywhere that doesn't have this little knob over on the left-hand side labeled volume. And if you're listening to a station and it's too low, turn it up. If it's too loud, turn it down. And the thing that I've often talked about is, and I might be wrong on this because I'm an old guy, but I don't believe that people scan up and down the dial and stop on the station that's the loudest. They stop on the station that's playing the format they want to hear. So I've never quite understood why one station wants to be louder than the other. I'm maybe I'm missing something there, but
Oh,
um,
Larry, through the years, many people have known that there's been a high level of competition between myself and Bob Orban. But on this topic, both Bob and I have said, you're right. There's a volume knob there. Now, that being said, I've been, in my time in radio, be it as a radio station engineer or having been in business now doing this, what it comes down to is we're dealing with a psychological challenge for program directors. Okay, it may be less today because of the digital world, but there was always this, as it was explained to me, that in the days when we didn't have digital radios, you would manually scan the dial. There was always that thought that if something jumped out a little bit louder, that it was bigger, that it was stronger, that it was better, that the signal, and now I don't know that one ever did a psychological study to prove if that's true or not. But I will say that psychological studies have been done on the effects of distortion and how it impacts how people listen. We know that, female listeners do not like highly compressed high frequencies, especially if they're distorted. But, if in all my time, I don't know that I ever heard somebody that said, I'm listening to this station because it's louder. I'm sure there are some program director buddies out there that would disagree with me, but you're right. I don't know that, am I going to say that it's a myth? I don't know. I think it's something that if somebody were to do like a research study on it, there'd be some interesting information to be learned by everybody, including us.
well, a good friend of mine in yours, Andrew Shep, once said that the loudness war was over, and he won because he mixed the Metallica album, which was considered to be the most aggressive album ever mixed. And he said, "So I won the war, so the war's over. So nobody needs to worry about it anymore."
It's funny you mentioned Andrew because many years ago, I have a friend in New York City who's who's an engineer in recording studio, and he invited me to New York because we went over to Sterling Sound, and their mastering engineer was telling me about how they were dealing with a problem And that being, they had artists coming in, and they were coming in and they would say, this is the CD of my competitor artist, and his CD is louder than mine. And the guy was trying to tell me about, quote unquote, the loudness war. And we all went out to lunch, and I was laughing all the time. I said, look, you guys are taking a page from radio. Radio's been dealing with this for decades. So there is something, I think it comes down to, that's why I mentioned, you know, a psychological study, research study, because I think it comes down to ego, you know, and I'm not blaming anybody, but I think it comes down to ego. And, but, and if it's true or not, it's, you know, it's not up to me to tell people that, you know, they're wrong. But I'm not going to sit here and say, guys, you know, you have to be the loudest on the dial. I've always felt that if you could have a competitive sound with some detail and quality, you know, to hold the listeners longer. And today, I mean, in broadcasting, you know, broadcasters are fighting for every listener because you have many different platforms that, you know, that the consumer can choose from. So sounding good, yet being heard on the dial is critical.
That's exactly right. I read an article a while back about some stations. I think it was in Boston or something. There were like 4 stations up there, and they were highly competitive, and they were always fighting with this loudness war. And the engineers, as a general rule, engineers get along with each other quite well. And these engineers would always go to Krispy Kreme and get coffee and donuts once a week. And they were sitting around talking, and they got to talking about how what a problem it was that every time they would come in the office, the PD would say, "You need to turn us up. Oh, Joe down the street, he's louder than we are. Turn us up." And he said, it's really getting to be a problem. And one of the guys spoke up. He said, "I tell you what we can do to end this." And they all said, "Oh, good. What can we do?" He said, "Why don't we all go to our station on Thursday night, readjust our processing where it's open and clean and warm and at a good level, and let's just see what happens." So they agreed to do that, and they did. And the next morning, nobody said anything except one PD. And he asked the engineer, said, "Did you do something to the processor last night?" And the engineer said, "Yeah, I made one little change on it." He said, "Man, we've never sounded better in our life. We really sound good on the air." Nobody was complaining about somebody being louder because everybody was the same level.
You know, Larry, I had a situation like that, but it was a bit more critical. This is like late 1984. I'm working in New York at Z100, and everybody pushed the modulation. I mean, everybody. And this is back when the AES fall convention was held at the old Hilton in Midtown Manhattan, and Bob Orban was introducing a CBS loudness meter, and Bob was showing it to an FCC friend, and the meter was pinning, and Bob thought he had something wrong with the meter, and the FCC guy basically said, "I think everybody's overmodulating," and he happened to be telling another friend of mine, Jerry LeBeau. He said, "You know, Jerry, you know all these guys in town. I want you to call them all up, tell them I'm leaving it alone for a week. If I come back a week later and the modulation's where it's at, $10,000 fine to whomever." And we all did the same thing, went to lunch, and all one Sunday night, went up to our, reset our modulation to be legal, and the exact same thing. No one said it different. And then the interesting thing was, this is back when Cap Cities had bought ABC, and they had their own FCC truck. And they came out one day, and they were going to scan the dial and measure everybody. And they measured everybody, and the only station that was over modulating was theirs. Which happened to be the radio station that Z100 used to make mincemeat out of every rating period. So
Let's talk about something I know that you're very much involved in now, and all the stations around both radio and television. Is not only do they have their main channel over there, main channel, but they also, especially in FM, you have HD2, threes and fours, and there is something running now. I think that you got all the way up to HD8, but they're also streaming over the internet, streaming their programming. Talk a little bit about the need for and the way that you actually look at it and adjust it, trying to get the processing that you use on your main channel audio is not the same processing that you would need to do on an HD subchannel or stream. Talk about that a little bit, if you will.
Sure. Well, first of all, we all need to understand that processing for processing for HD and streaming are pretty much one and the same because you're dealing with data reduced audio. Okay. That said, it's altogether a different technological platform. And to address FM for a moment, processing for FM stereo and processing for FM HD are two different animals because in the world of FM stereo, we're dealing with something called preemphasis. And preemphasis is the high frequency boost. And in the United States, it's 75 microseconds, which, to give you an example, basically means the audio frequency response is going to be flat to about 2.2 kilohertz. And then at 15 kilohertz, the boost is somewhere like 17.4 dB. So you've got this huge boost of high frequencies. You do not have that in the HD side. To back up for FM stereo for a moment, we apply specialized processing to deal with the preemphasis. That said, you do not want to take that processed signal and stick it in on the HD side or on the streaming side because of all the processing functions that are done to manage preemphasis. An audio codec doesn't like that. And what you'll end up with is a combination of probably added coding artifacts or possibly other distortion components. So that said, what you want to do, and most products are available today, the processing system will handle all the multiband sections pretty much the same. And then just before you get to the end of the path in the processor, the signal gets split apart where one direction it goes for the FM stereo side, dealing with preemphasis, and then the other side, it utilizes specialized limiting for dealing with a codec. Now, in dealing with a codec, there's a few things we need to consider. If you're dealing with something at a lower bit rate, because I know in the HD world, if you just use HD for the entire channel for your audio, you've got 96 kilobits per second to utilize. Well, you can pretty much set up your audio processing without much difficulty insofar as dealing with coding artifacts. But if you start dealing with HD2, HD3, you're cutting down, you're having to parse the bit rates. So now you're dealing with lower bit rates, and then you have to set up the processing for the coded audio so that those lower bit rates don't get into trouble. And, most products, ours included, and I believe others, have tools in the processor so that, in dealing with lower bit rate signals, you minimize the effect of coding artifacts. And that's the critical part. Many years ago, we did some work. There was a company that was doing these before you could have everything on your phone. They were doing these. It was kind of like books on tape, but it were books they were using Windows Media at a very low bit rate. And they came to us because the coding artifacts were it was annoying. It was so bad. And we came up with a method to manage the audio where the audio was intelligible, the coding artifacts were suppressed, and they were able to achieve everything they wanted to hear. So we've applied it's a function we call census that we've applied in our applications so that at lower bit rates, which can happen in, you know, the HD2, HD3, HD4, or on the HD side at AM, to enable that signal to sound as good as it, you know, as good as possible.
I'm sorry, I'd muted my microphone here for a minute.
It's okay.
Yeah, when you start trying to stream audio on the different services and all, one of the problems that we seem to find out is that every stream service is different. I mean, they're not all the same. And
Right.
I don't know whether it's possible in the broadcast environment to tailor it for each one of the, you just have to pick one, I guess, and sort of, I know I again mentioned our good friend Andrew Shep. Somebody asked him about that when he mixed audio for a record. Does he tailor it for going out on streams, YouTube or Facebook or places like that? He said no. He said, I try to create the best mix, the cleanest mix I can, and then let the streaming people do whatever they want to. Because he said the problem is with streaming services, they change all the time. What they do today, they do something different the next day. So I guess in the broadcasting realm, you just have to send it out, and whatever they do to it, you got to, not much you can do about it.
Well, and first of all, I agree with Andrew, you know, because if he's mixing something or producing something where it's, you know, he's targeting to make sure that it sounds nice on this streaming service as compared to another one, that's you know, you'd be shooting yourself in the foot. But that's where, you know, the use of a dedicated audio processor for a streaming service or HD, you know, you know, you've got a lot of tools in the product, such that, you know, you in the same way that we spend time to get the processing to sound good for over the air, you've got to do the same thing with regard to if you're going to be streaming your station, or you're taking other feeds, excuse me, you know, and mixing it into your programming. You know, that's where you know, basically the generations of product that's available today are all capable of, you know, outputting great sounding streams at all bit rates. You know, we work with a number of the both broadcasters and streaming services, and they all, you know, they'll send us notes and check this link out. Listen how great it sounds, and you know, I'm honored that a lot of our product is being used in these applications, and everyone I've listened to, it's not like I've heard something that I had to like go, wow, you know, they're missing something, or they didn't, you know, they're overdoing it, or they didn't set it up right. So, but again, a lot of it comes down to, and unfortunately, I think the challenge for today's broadcast engineers is that since a lot of the guys are spread so thin, is being able to get the time to, you know, one, learn a product, and then once you learn the product, being able to apply it in the manner that it's needed. Wind the clock back a number of decades when Goomba here was working in radio. You know, I could take a day and, you know, be putzing around with the audio processing and listening to it critically and tweaking and, you know, doing whatever. And I'm, you know, when I talk with folks today, either through communications or at trade shows, you know, a lot of these guys, they're not afforded a lot of time to be able to, you know, dig in and do it. And to that, I hear it. I understand. So, you know, that's, you know, without rambling on too long here, you know, one of the things we're working on is how do we provide the tools, you know, to make it somewhat easy for someone to, you know, get something on the air or online, and achieving, you know, the signature that they're looking for. And going forward, you know, I think this is an area, to be honest with all of you, not that I'm gonna be honest with all of you, I think this is an area where AI is going to come in and be a big player. You know, we're gone will be the day where you got the program director bothering the engineer. Program director will take one of these and say, "Hey, Omnia, I want, I need a fat low end." And then the Omnia is going to basically take that instruction and, do it. And then the program director will say, "Omnia, it's too broad, tighten it up a little bit." And then, the machine learning will then be able to do that. And I think that's a direction we'll see things go.
Yeah, you and I talked about that some time ago, and about a process of how you do that, and you talked about you need to have a good monitoring environment, and the engineer really needs to develop the ability to listen correctly and acclimate his ears and know what good sounds like. I know in the pro audio field, that's a big thing, is learning how audio is supposed to sound. I heard somebody talk about that was doing, I think the guy, John Cooper, that front of house for Bruce Springsteen, said you really need to listen to the instruments live to see how those instruments sound, and then translate that in your system, but for the house. And I think the same thing is true, that an engineer needs to listen, not so much how to tailor the sound, but first of all, to listen and find things that's not supposed to be there. Simple
You're
things
right.
like hum, buzz, crackles and
Well,
popples.
there's that, but there's something else too. And that is one of the things that, and for some reason, my ears seem to be very in tune to what I call intermod distortion. And intermod distortion is when something like very heavy, fast compression. And the example I'll give is take like a good, sharp, well-recorded snare drum hit. It should always have that whap sound. And a lot of times when somebody says, "Hey, here's a competitor's product, what do you think of it?" And I've got a handful of audio tracks that I put through it. And when I start hearing a lot of the transients getting sucked out, or that, heavy, dense, heavy compression sound, which is built up by intermod distortion, that's all part of learning how to listen to signal processing. And by example, I was working on something a number of years ago, and the opening drum hits to the song "Babylon Sisters" by Steely Dan. And I'm running it through this algorithm I'm working on, and those drum hits, I'm just going to tell you guys, excuse my language, they sounded like shit. And I'm like, what the hell's going on here? And sure enough, I'd done something stupid in the development process. I fixed it. But there are times, I mean, because that's so well recorded, and a lot of their material, their engineer, the late Roger Nichols, was such a stickler for getting it right, that it parallels what you're saying, Larry, about being able to hear something live. Now, in the case of Bruce Springsteen's colleague, he hears that. We don't have that. So that's one of the things that I would hope that some of our attendees today, that they have like a little, let's say, for lack of a better term, toolbox of tunes that they can use to determine if something's sounding right or not. A short, quick story out to this effect, and this is how I learned it. Many years ago, when Steve Church and I were first introducing the Zephyr audio codec, we got a note. Well, back then there was no email. We got a fax from this engineer, Lars Mossberg, at Swedish Radio, that said that when he played this certain segment of classical music through the Zephyr, in one channel, he heard this little noise in the background. And I'm like, this is crazy. Well, sure enough, I had to send away for some imported CD and played it, and it was there. And here, I eventually met Lars and became friends with him. Lars would walk around and listen to stuff in like this high quality headphones. And that guy's ears were so in tune you know, that going forward, when I would want to evaluate an algorithm for signal processing, I would send stuff over to Sweden and I'd say, hey, Lars, what do you think of this? And, you know, he gave it to me honestly, you know, and a lot of things that we eventually ended up in our products that were of benefit were because I learned how to listen to things a little bit better. And it was, you know, stuff like that. And it plays here with what we're talking about.
There's actually, again, we talked about fine lines before. There's actually that same fine line when you're adjusting a processor. I've always been taught that you actually supposed to listen to it at a low level, because your ears, as most people know, will trick you. They have automatic gain control and frequency compensation and all. So most professional mix engineers will tell you that. Chris Lloyd-Alge, another Grammy-winning mix engineer, said he mixes at such a low level, he can hear the guy tapping on his iPhone sitting next to him. But he said, because if you listen too loud, your ears will begin to trick you, and what you're hearing is not really true. So an engineer, when he's adjusting the processor, needs to get in a quiet environment and listen to it. And one of the key things I've learned is never turn but one knob at a time. Just make small adjustments, and I think you shared this on one of our seminars before, that you can't adjust a processor in 30 minutes. You
That's
can't
right.
do it in an hour, and it takes sometimes days to get it exactly like you want it.
I'm in full agreement. And many years ago, I was fortunate to work with a disc jockey program director who unfortunately is not with us anymore, a gentleman by the name of Mark Driscoll. And Mark would call me up. Whatever market he was at, I'd go down, help him. And we'd get in the car and he'd be talking to me and we'd be driving around. He'd have the station on very low. I mean, meanwhile, we're just chewing the fat. He'd be asking me about the steam engines or what's going on in life and all that. And we'd drive around for about 20 minutes. We'd get back and say, hey, Frank, processing sounds great, because he had it at a very low level. And he had that ability to tune in and lock it in. Another thing that supports this is that, you know, remember the Fletcher-Munson curve, you know, as you go louder, that Fletcher-Munson curve in our head starts to flatten out. And you basically desensitize your hearing. And the recommendation, aside from what you're talking about, the lower levels, is you only want to, and even if you're going to turn the level up a little bit, only do it for about 20 minutes and then go away, let your ears rest. And here's why. Because, and I use this analogy, and feel free to go do this. I call it the hot water test. Go over to the sink, turn the hot water on, let it get really hot, then take your finger and pulse your finger to the hot water. Every time you pulse your finger to the hot water, it's going to feel hot. If you take your finger and stick it under the hot water, for the first few seconds, it's going to feel hot. Then the nerves are going to desensitize and you'll adapt to it. It's not going to be hot anymore. The ears do the same thing. This is why we have to, you know, allow our ears to breathe. And also it plays to the whole and setting processing that, you know, that you're keeping your finger under that hot water. That's analogous to having a very highly dense signal. You know, the ears are going to get desensitized. That's why if you have some dynamic range in your sound, you know, every time you touch that hot water, it's going to it's going to feel hot, but that dynamic range, every time you lock in, it's going to appear louder. Last thing I'll say on this topic, you know, back in my day at Z100, I will tell you that electrically, WPLJ was electrically louder than Z100, but to the ear, Z100 sounded louder because we had some dynamic punch. And you'd hit 100.3, it's like, wow, there it is. It had that, you know, like Roger Daltrey would always say about the Who's music. It's like, you know, punching you in the nose and saying, I love you. That's the analogy you want to make, you want to use and make it happen.
That's exactly right. The same thing, you know, that you're talking about the Fletcher-Munson curve, and where you see the sensitivity of the ear. Loud sounds will mask sounds. It will actually change the sensitivity of the ear. And
That's
you
right.
can, there may be a song playing that maybe got some low level sounds, a piccolo or something, and all of a sudden the guy on the timpani just, you know, goes a big roll off on the timpani. Well, the sensitivity of the ear moves up, and you don't hear the sounds that's masked down under it. The
Right.
knowledge of that is, and I always share this at the class, is sort of like when your mother-in-law comes to visit and she's in there just yakety 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 yak. Well, you go in the kitchen to get you some water, and you turn on the ice maker, and it makes a lot of noise, and then you don't hear the mother-in-law talking anymore because your sensitivity of your ear changes because of the loudness of the ice maker. Now, we don't want to say that around your mother-in-law, but that's sort of the way it works.
Well, I was very fortunate in the sense that when there was a mother-in-law in my life, um, they were wonderful people. But it brings back, and I'll probably get in a lot of trouble for saying this. It brings back something that I once saw in Amos and Andy. You get the axe and I get the saw, gonna cut off the legs of my mother-in-law.
One other thing I wanted to talk about here, that engineers need to be aware of before they actually start tweaking on it. And old Joe Gilder, who is he does a lot of audio blogs for Prasanna, console manufacturer, and he has an acrostic called it's like GIRATS. Get it right at the source. No matter what you do at your station, if it's not right at the source, no matter what processor you have,
That's
then you're
right.
going to be fighting that all the time. So it's so important to get the sources right before you start messing around with the processing.
Agreed. Agreed. There's, one of the sad things that occurred, a while back was with, a lot of the hyper compression that was done in mastering. You take some of that material, run it through a processor, and it sounds really nasty. But more importantly, you want to make sure you've got everything along the lines from, how things are operating in the console all the way into the, signal processor. And something that I've suggested to people is that, especially in the digital world, is if you calibrate everything so that, at all the stages, like with a tone, if you've got it set at, minus 12 dBFS, that it shows up at minus 12 dBFS and the STL or the link, and then at the input to the audio processor, it's minus 12 dBFS. Then you can be guaranteed that whatever's going on the console is what's happening going into the audio processor. That helps in a great way to see to it that, through your system, because remember, we're talking about a transmission system. And if you're only as good as your weakest link. So if you've got everything done, set to where everything's, for lack of a better term, in sync, level wise, you're putting together a great foundation in your system to, put something on the air that's going to sound amazing.
That's right. The levels should not go up and down in the system. You should be able to go anywhere in your plant and the
Right.
level be the same. It's
That's
just the old, we call it in pro audio gain staging. And so
right.
that's so important to do that. Let's we still got a few more minutes here. Let's talk a little bit about the future, what we see coming up in the future in processing. You mentioned using AI, and now we've got already in place some virtual processing. Talk a little bit about what you see coming up in the future with processing.
Well, our organization has put a lot of time and effort into virtual platforms, containers, running in the cloud, things of that nature. As a matter of fact, the IBC convention just wrapped up yesterday, and Our new Forza FM received numerous awards for best of show. And basically what it is it's audio processing that's not, in a box. I mean, well, the box would be if it's, running on a server, or it's, somewhere in the cloud, and so for the future, and I say this with sincerity, we have to walk as an organization, we have to walk a line and serve two masters. One master is, I know there are broadcasters out there and probably some folks on this webinar that are saying, I'm not comfortable yet going into the virtual world. I want a box. And by the way, this was a hard discussion I had to have with our people, because they wanted to, do a track meet into the whole virtual world and abandon, making boxes. I said, we have to serve two masters. Now, in this world, okay, it's the same software. Okay, the algorithms are exactly the same. It's not like the virtual product is going to be, I realize Forza FM is, it's not running all of the Omni 11 stuff, but at some point, Omni 11 will show up in the virtual world. But it comes down to the platform that the user in our industry wishes to have. So that being said, we will continue to support, having a box that's an audio processor, and it'll have all kinds of features and, hoo-ha and what have you. And yet at the same time, we have dedicated effort that's, making things happening in the virtual world, because we now have, I think minus, maybe just a few items, we can create the entire infrastructure for a broadcaster virtually. So, that's item number one. The other item, and I'm not just saying this because it's the buzzword, is, how do we, and where are the benefits of applying things like, added intelligence, you want to call it artificial intelligence, what have you, but there are, there are benefits there to be had. And through that, what's not to say that we're not able to have the capability of, information come back to the processor from radios themselves with respect to how things are, how the whole system's working, meaning the whole transmission path. Before we got on the webinar, we're talking about, Atmos and metadata and things of that nature. Yeah, that's nice and that's cool, but that's just the beginning. So, we've got, our crew are feverishly working along with myself on, what are the tools that are going to be needed going forward, and how do we serve those platforms? Because, it's going to be a while, I think. And I don't think, to be honest with you, at least probably in my time, for whatever amount of time, I'm around, if you will, that will ever, I don't think hardware will 100% ever go away. I mean, there may be some people that tell us that'll argue that, but I think there's still going to be broadcasters that their comfort level is, I go out to the transmitter room, or I go to the master control, and the box is right there, and I do this, that, or the other thing. So that's my story, and I'm sticking to it.
What do you, I know you keep up with all the developments and experiments going on around the world. ABU has been working for a number of years on something called LUFS. Where do you see that going, or is that something that may be adoptable in the US?
I'm a bit of a renegade, and I'm a bit of an outlier, okay? And why do I say that? Because you get a lot of these groups that want to create standards, and nothing against our brethren in the international world, but that's their comfort level. I can't tell you how many times I've been to broadcast facilities, working with, guys in lab coats that want to argue about, some theoretical specific in a FM stereo composite signal, yet what they're showing me doesn't sound all that good, okay? You know, as you even said earlier in this webinar, you know, when it comes to loudness, it's like there's a volume control. And, you know, there's, you know, we offer it only because the marketplace demands it. You know, we have the ITU 1770 loudness limiter that can be optionally switched on and off, and you know, for streaming applications. And you know, we put the thing in there based on the specifications of how that limiter is supposed to work. But there's times, you know, I hear audio content that goes through it that just doesn't sound right, you know. So where am I? I'm one of those that, you know, if I was working in radio, and you know, I'd probably be pushing the limits. I'd probably be stepping over the line, not to be mean or nasty or competitive, but in trying to make things sound as good as they can. And I don't know that some, you know, requirement or some audio organization, be it the ITU or the AES or what have you, you know, because I know AES, you know, they spent years coming up with this streaming audio, you know, level standard. And I used to sit in on their meetings, and guys, I got to tell you, you know, and if any AES members are on this webinar, I apologize in advance. I used to sit in those things and say, I'd rather have my teeth drilled with, you know, with a dull drill bit and no Novocaine. I mean, it was just like, come on, you know, you can argue ad nauseum about things, but somebody's got to do something. And I'm a doer. I'm a doer. I'm not one to sit around and want to have meetings and debate specifications. I'm a doer. So, you know, now if there's somebody comes up with some, you know, dedicated research that says why something needs to be done a certain way, okay, I'll pay attention. But I haven't seen that as of yet. I think it's just a lot of, you know, academia, you know, and, you know, Steve Church and I, may he rest in peace, we used to, you know, Steve was more academia than I was, but Steve was also one of that just said, hey, Frank, if it sounds good, F it, if you know what I'm saying.
I think that procedure or that policy actually came about because of the situation with television years ago with the COM Act, where the difference in levels between programming and commercial content was so bad. And as those of you
It's still bad.
Yeah, well, it's
Larry, it's still bad. I sit out my television setup is one where, you know, I have a HDMI switcher, and one output is the cable box, another output is the Roku, and another output is my DVD, my Blu-ray player. And I put on the Roku thing, and you know, I'm looking at all the previews, and they're screaming really loud at me, you know. And then we put on a movie, you know, it's like, you know, and even over the air, you know, it's like on Sunday, I'm being a fool, you know, wasting my time watching the NFL, the No Fun League. You know, one game, you know, everything's nice and balanced and you can hear everybody. You go to another network. I mean, this is network television and the audio levels are all over the place. So, you know, I'm not sure that the Calm Act did a lot, you know, and if anything, there's more that can be done. So, you know, I'm sure you're right. A lot of it may have come from people complaining about television stuff, but it's still not right. It's still not right.
Yeah, it got so bad, as you remember, people were complaining, and they began to complain to their congressman about
Yeah.
the differences in the audio, that you'd be watching a soap opera and then Joe Bob's used car salesman would come on and blow you back in the kitchen. And
Yep.
so the congressman went over to the FCC and said, you guys got to do something about this. So that's when they came up with that. And theoretically, it had a level, a preset level that was supposed to be the same for all sources, all program sources. And I think it worked a little bit when they first put it in, but it sort of Add insertion on cables, that's another problem that we won't get into. And I
Actually,
think,
Larry, little bit of history for you is that it was a congresswoman. She's from the San Francisco Bay Area, and our television division, linear acoustic, were very involved with that. And when it came out, we saw to it that the television audio limiter in our products adhered to the CalMac performance, and we sold a boatload of them. And you're right, for a while it appeared like things were okay, but things have gone, you know, goofy, and they've gone goofy again. And the few times I've tried to sit down and talk with people about it, you get so many different opinions today where people are locked in on their opinions. It's almost like, and I'm not going there, guys, but it's almost like talking politics today. I mean, the level of division in what folks feel needs to be done, it's like apples and oranges as compared to, like, let's come together, as an industry, because it's a small industry when you think about it, and put our heads on the table and do some work. Don't come together and, be shoving, specifications, and this, that, or the other thing in each other's faces. Come together, like do a workshop somewhere. It could be done at an AES thing, ABA could host something, who knows, NAB, and do it, and where you have information you can hang your hat on. And then and only then will progress happen. But business gets in the way, and crazy things happen.
yeah, and I'm afraid if LUFS ever makes its way in to radio, that same problem will happen in radio as it did in television.
I, you know, I've had, you know, I've had friendly debates with folks over in Europe that, and by the way, it is sort of in Europe. They have this thing called the multiplex power limit, and not all countries adhere to it, but it's you can look it up. It's called ITU BS 412. It's a power limit of the multiplex signal, and it can't go beyond 0 dB. And if you have one of our products, and I think some of the others have it as well, if you were here in America, if you were to turn it on, your audio level coming out of your radio is going to drop by about 12 dB.
Yeah.
And it's all tied into, over there they had, I want to say was it Switzerland? It was one of those Scandinavian countries where apparently this has been on the ITU books for decades, and somebody started invoking it. And I think in France they recognize it, but they don't go to 0; they go to +9. I mean, and that's still packing a wallop insofar as a dense transmitted FM stereo signal.
Well, Frank, we sure appreciate your time today and sharing your thoughts and your expertise on this. And I wanted to make sure, John George, did you have any comments you need to make? I forgot to introduce you as our co-host. I'm sorry.
No, that's perfectly all right. It's always a learning time when Frank is on. I do want to mention a couple of things that we need as reminders, and the first one, of course, is the fact that the FCC ETRS form is due October the 4th, and we don't want anybody to forget about that. And while we're not having a national test, or at least we don't think we'll have a national test the next few months in this year, the ETRS Form 1 is required to be completed for all stations and all EAS boxes. And if you have participated, as I'm sure most of you have in the past, basically when you log into the form, it'll automatically fill in most of the parts and make it very easily. And one last thing, filing fees are due September the 26th. There have been issues with the website. I understand, and I don't know, Larry, if you've heard anything new, but I believe they have it fixed and will be notifying the broadcast stations later today if they haven't already that you can now go on the website. So, a couple of things from the FCC. And again, Frank, thank you very much. It's always a pleasure to participate with anything you're a part of.
Yeah,
Well, guys,
the thing with the with the fees got a little comical. They opened it up for everybody to file their filing fees, and some full power FM showed up as translators, and some translators showed up as full power. So I think there was a little glitch in the system that somebody didn't work out.
Definitely.
Yeah. Frank, again, thank you for your time, and always enjoy
thank you for
having
the
you with me.
opportunity to spend time with you guys.
Okay. Our next webinar will be coming up in October 15th. Our special guest at that time is going to be our good friend Wayne Presida, who is going to be talking about cloud computing, cloud operating, broadcast station, and that sort of seems the way things are going today. So Wayne will be with us. Mark your calendar for that, October 15th. So thank everybody for joining, and we'll see you in October.